Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. My name is Siti Madiha Husna binti Suhaimi, metric number 1170866. My supervisor is Professor Madia Dr. Muhammad Hafiz bin Muhammad Isa, and today I would like to present about my review paper entitled Review on Influence of Ceramic Material toward Polymeric Membrane Physico-chemical Properties. So for the introduction, the researchers have developed several membranes in order to treat the water. For example, the microfiltration, ultrafiltration, nanofiltration, forward osmosis, as well as the reverse osmosis membrane. So the membrane materials are basically based on the polymer materials, ceramic materials, as well as the mixed matrices, or we call it as composite materials. Since the polymer materials or polymeric membrane consists of several disadvantages, including low in thermal stability, low in hydrophilicity, as well as it tends to fouling. So this review is focused on the influence of addition ceramic materials toward polymeric membranes in terms of the morphology structure, TGA analysis, and etc. So in this review paper, I have focused on three types of ceramic materials, which is the halloysite nanotube HNTs, montmorillonite MMT, as well as the nanoclay. So each ceramic materials have been incorporated with various type of polymeric membrane, such as the HNTs is incorporated with the PSF and PVC membrane. The MMT is incorporated with the PVC and PVDF membrane, and the last one is the nanoclay is incorporated with the PES membrane. So the addition of those ceramic materials into the various type of polymeric membrane, this review is focused on the physicochemical properties in terms of cross-section morphology and its WCA, water contact angle, membrane properties and PWF test, the TGA analysis, and the last one is the membrane performance. So we go first of the cross-section of the membrane when adding the HNT into the PSF membrane. So the results show that with the addition of low loading, which is the 0.2 and 0.5 weight%, it gives the finger-like sublayer structure. Meanwhile, the narrow stripe structure is formed with the addition of 5 weight% of the HNT's loading into the PSF membrane. Unexpectedly, in terms of the pore size, the M3 membrane showed the smallest pore size. This is different from the other reports, at which the pore size will increase with the addition of ceramic material. But in the M3 membrane, it doesn't suit with the report. So the researchers assume that the gain in hydrophilicity has not been enough to contribute to the rapid solvent-non-solvent demixing process. So that's why the M3 membrane show the smallest size of pore compared with other membranes, even compared with the neat PSF. So next, the study of HNTs, addition of HNTs towards the PVC membrane. In this study, the researchers used the net PVC, 1 weight% of HNTs, 2 weight% of HNTs, and the highest one is the 3 weight% of HNTs. So in terms of cross-section image, it showed a similar result with the HNTs in the PSF membrane, which is it formed the finger-like sublayer with addition of ceramic materials. But in terms of size of pore, it showed a decrement at PVC HNTs3, which is the high loading or the high content of HNTs. Initially, the size of pore is increased at PVC1 and PVC2, but it is decreased back at the PVC HNTs3. It is due to the agglomeration that is occurred at PVC HNTs3. So the figure above show the structure of cross-section of those membrane as well as the pore size, and the figure below show the agglomeration that happened in the PVC HNTs3. So we move to the next type of ceramic materials, which is the MMT. So MMT incorporated with the PVC membrane. So the researchers use a net PVC, 2 weight% of MMT, 6 weight% of MMT, and the last one is the 10 weight% of MMT. In terms of cross-section structure, it still shows that with addition of ceramic material, the finger-like sublayer will form. The agglomeration still happen towards the PVC MMT membrane, at which with high loading or high content of MMT will lead to the agglomeration. But in the study of addition MMT towards the PVDF membrane, there is no such agglomeration, at which in this study the researchers used a net PVDF, 1 weight percent of MMT, 2 weight percent of MMT, 4 weight percent and 6 weight percent of MMT. So the highest loading of MMT is 6 weight percent, and it showed the biggest pore size form because there is no agglomeration occur. So the next type of ceramic material is the nanoclay incorporated with the PES membrane. So in this study, the researchers used the net PES membrane, 1 weight percent, 2 weight percent, and 3 weight percent of nanoclay loading. So same goes to the nanoclay, which is by addition of this nanoclay into the PES membrane, it will form the formation of larger pore size, as well as it can show the larger macrovoids in sublayer. So the next physico-chemical properties in this review is the WCA. So all of the study show that with the addition of HNTs, MMT, and nanoclay membrane incorporated with the polymeric membrane can decrease the WCA value of each membrane. This has happened due to the addition of the hydrophilic agent, which is the ceramic material itself. So the hydrophilic agent is not only affecting to the decrement of WCA value, but it is also give the increment or the improvement toward the pure water flux, which is the PWF test towards the membrane. So basically, if we add more content of the ceramic materials, the hydrophilicity will increase too. It is because the ceramic materials behave as the hydrophilic agent, which consists a huge amount of hydroxyl groups. Thus, it will improve the PWF test. However, it showed the dissimilar at the nanoclay composition. We can see from the graph, it showed that the highest value of the PWF test is at 2 weight percent of nanoclay loading compared with the 3 weight percent of nanoclay loading. There is no other reason the decrement shown in the graph is because the 3 weight percent of nanoclay loading incorporated with the PES membrane is due to the agglomeration. The next physico-chemical properties is the TGA analysis, which is this TGA method is used to measure the degradation of temperature when we add the ceramic materials in the polymeric membrane. So the results show that with the addition of the ceramic materials into the polymeric membrane can improve or enhance the degradation of temperature, which can give the high value of TGA measurement. Or in other words, with high content of the ceramic material can give the maximum value of the TGA curve. So we go to the last physico-chemical properties, which is the membrane performance. So membrane performance is divided into two, which is the BSA rejection as well as the flux recovery ratio, FRR. So for the BSA rejection, it can conclude that with addition of ceramic materials can increase the BSA rejection of the membrane. However, if it is too much content or if it is too high content of the ceramic materials, it will lead to the agglomeration, which is the blockage of the pores, which can decrease the BSA rejection. So this is why the 3 weight percent of HNTs loading in the PVC membrane and the 2 weight percent of nanoclay loading in the PES membrane show the highest value of BSA rejection when it is compared with the others membrane, including the highest content of the loadings. In easy words, we can say that it is not necessary we have to add more content of ceramic materials to get high BSA rejection. So next is the FRR. So FRR is a parameter that need to be highlighted in order if we want to measure the anti-fouling characteristic of a membrane. So overall, the addition of ceramic material will increase the hydrophilicity of the membrane, and when the hydrophilicity is increased, the negative surface charge of the membrane also increase, which will lead to the increment of anti-fouling characteristic of the membrane. Hence, by addition of ceramic materials toward the polymeric membrane, it can increase the BSA rejection as well as the flux recovery ratio. So, in the conclusion, it can be said that with addition of the ceramic materials into the polymeric membrane, it can give the enhancement or the increment in terms of the physico-chemical properties, since the addition of ceramic materials can increase the hydrophilicity, as the ceramic materials is a hydrophilic agent. As it can be seen in the figure, with addition of ceramic materials, it will increase in hydrophilicity and it will lead to the increase in porosity, PWF test, BSA rejection, and it will decrease the WCA value. So for the recommendation, it can be said that it is good to adding the ceramic materials into the polymeric membrane. But if the addition is in the high content, it will reduce the function of ceramic materials on the polymeric membrane itself. Thus, in order to get the best result, we have to control the addition or the measurement of the ceramic materials towards the polymeric membrane. And we also have to consider what type of polymeric membrane that we use, as we want to determine what is the best ceramic materials can be incorporated with. So those are several journals that I have been referred in order to complete my review paper. So thank you so much for my evaluators for your time to watch my video's presentation. Stay safe and Assalamualaikum warahmatullahi wabarakatuh.